Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. Yes, but we can't find any conversation. Nobody will dispute anything I'm saying by citing some sort of evidence that the truth is otherwise. So if I say there's no evidence of it taking 25 times the fuel to spin something 5 times as fast, and it's an elemental, fundamental premise of physics, nothing. They can't, they can't provide a defense for the statement because it's an indefensible statement. It doesn't happen in reality. And the fact is that their elemental theory of energy is wrong. It's not accurate. It doesn't happen in reality. There is no 1/2 mv squared. And the important part is there's no velocity squared as a function in the universe. The only time it could ever be useful is in some contrived math where you've taken objects, any one of which you could square, and get the same value for your product. But there's just no geometry to a squared velocity. But anyway, so this is on heat. So this is really the big one. It's a very important subject recently for me. Because I never really thought about heat as anything other than just some sort of waste vibration, that moves something, moves through something. And yes, it's energy dissipating. But I never thought about the fact that, when there's heat in an object, it has to eventually dissipate as radiant energy. So it has to be turned into some sort of infrared radiation. And that somehow that infrared radiation has to be cycled. I mean, it has to go back into the system somehow. So the very fact that, that people talk about energy conservation, but they really don't think about the fact that, yes, okay, energy goes from big things to little things. And that's a tendency, and it's a tendency we take advantage of. But, okay, you have to figure out how it gets back into the other forms that we use. So the whole cycle of energy created by gravity is so, I hate to say obvious, but, frankly, and I missed it. Everybody misses it, because you're taught not to see it. And it's so fundamental because you're taught that this is just some sort of bent geodesic, that gravity is not doing anything. Okay, to change the universe, it's just making things move towards the earth. And no, it's actually creating momentum, and then it's creating heat, pressure and heat. And you have to explain how that mechanism of creating some physical substance of energy can get back into something called a bent geodesic. Well, anyway, so there's so much to this subject. And, we'll do our best to be fair to it. So I'll just draw some stuff, getting to this gravity subject, and try to do it in some, in some way that makes it understandable that everything is radiating energy. Everything. Nothing is at zero temperature, technically. Anything in the universe is obviously interacting with a universe that has a temperature in it. It has cell phone calls, and it has noise that you know of. So obviously it has to in some way interact with that field, and it can't just reflect it all. It has to absorb some of it first and then reflect it. All right, and that's the key point to what happens in gravity, is just clearly the amount of energy going in is different than the energy coming out for an instant of time. Now, over a period of time, it balances out to a kind of equilibrium. If you didn't recognize that the push goes in first, okay, the push is always first. And, that means the push goes first, the counter force comes later. And that's the differential you could even see with a spring. All right, so how to get to this? I mentioned in another video about how you could imagine rain, and you could imagine a cloud above you, and then you could imagine that all the rain from that cloud getting focused into one point. And that's what gravity is essentially doing. It's taking the energy over a big giant surface of the Earth, the pressure, and it's bringing it down closer and closer. It's bringing all that pressure into the center of the Earth. So the center of the Earth is molten and hot because all the energy, okay, that hits this whole outside of the surface is basically doing what I just described. That is in the inverse square kind of way. That is recognizing a condensation in 2 dimensions. You know, it's shrinking this way and it's shrinking this way in the amount of space that all of the heat, all of the noise ends up going. So that might be better. And so a tremendous amount of noise, energy, heat, whatever you want to call it, thermal stuff, is being focused by gravity into the center of the Earth. And this likewise has to do the same thing where it has to radiate back out eventually. So it goes in here, okay, and it comes out this way. And the fact is, it's at equilibrium, okay? The Earth doesn't get bigger and bigger. It's not consuming energy and keeping it. It's only keeping it for a very short time, you could say. And so that's the gravity that you fall into, is the fact that any energy going through the Earth takes a little longer to get through the Earth, okay, and come out this side, than the energy coming from the universe. So the energy coming from the universe is now real, and the energy coming up from under the Earth that should have hit you if the Earth wasn't there, it would have hit you, but it's not going to hit you in time. It's going to show up too late. And that's the differential you fall in. But the key point is there's this huge amount of energy inside the Earth, and what you're doing is basically the same thing in reverse. This inverse square law just goes in reverse on the energies coming out. So it can be, 4,500 degrees Celsius, okay, in the center of the Earth, and it can be, minus, let's say, 50 degrees on the surface of the Earth, let's say without the sunlight in the atmosphere. That's how cold it would be. But minus 50 is, plus 250 Kelvin. Okay, so you have to understand this on this absolute kind of temperature scale, that it's actually hot. Okay, that minus 50 degrees is cold for us, okay, as biological organisms that depend on liquids and gases to function. But it's not cold relative to absolute zero. So you're taking a gigantic density of Earth, it's out here, you can understand the shell of the Earth is huge, huge. And so you're taking this 4,000 degrees and spreading it over this gigantic amount of material as it leaves the Earth. So the temperature goes down before it gets to the surface. But that's the idea, and the sun is just doing the same thing, except the sun is hotter and it's not as dense. Okay, so it's only 30 times. I mean, the size is 1,000,000 times, but the density, is only like whatever. I don't know what the exact number is, but it's not that. The gravity is only 30 times greater. The gravity on the surface of the sun would only be 80, okay, meters per second. Not that high. Not that impressive. Anyway, I think it's 80. Well, anyway, it doesn't matter. It's not the number. It's not 1,000,000 times more than the 9.8 meters we experience on Earth. So anyway, so the sun's on fire because the sun, instead of being 45 degrees, because it has so much pressure, because it's gigantic and it does have more mass, total mass. So it's maybe 7,000 degrees, and it's 7,000 degrees, and considering the fact that it doesn't have a bunch of heavy elements, the heat gets to the surface and then we see it. There's a bunch of flames and fire and stuff, okay, that emits photons. So the Earth would emit photons. It's just that it's made out of all this dense matter, and it takes a lot more energy to get that to start glowing. So it doesn't have quite enough pressure internally to get hot enough to start glowing. Okay, but that's it. So, but the idea is a simple one: is that the Earth is obviously doing the opposite of this entropy problem, in the sense that it's consolidating the energy, and in this very hot cores of all these gravitational objects, and that is the source of the rest of the energy that we take advantage of, the kinds that we can take advantage of. But it really doesn't make any difference. It doesn't matter whether you put your boat in the force going into an object, or you put your boat in the force coming out of an object. It's the same thing. But clearly in the case of a gravitational body, you have to go with the direction of the stream, and the stream has a direction because there is a differential between the energy coming from the outside and the energy going out. There is that delay, and that's gravity. All right, so there's no conservation in the bent space theory, obviously. There's no mechanism that takes the infrared radiation that ultimately has to leave the Earth, some form of microwaves and radio waves and whatever, some sort of radiation, and how that radiation gets converted into bent space, when the obvious answer is no, that radiation gets converted into creating gravity on other things in the universe. The radiation travels through space. It gets to the moon, for example. The Earth's radiation hits the moon, pushes on its surface. So everything is radiating and everything is collecting. And that's you could argue, the yin-yang, if you were going to use kind of mushy terminology. That's the conservation mechanism. All right. Find something to clean this up. All right, so let's play the video.
Professor Dave here. Let's talk about heat.
He knows a lot about the science stuff. Professor Dave explains.
So, heat, is just movement. Just like any other movement, except it's little things moving. Atoms, generally. But obviously, I think you could understand like plasmas and other things that require, they have ionization associated with them, where electrons are being transferred and thrown off, that the electrons and protons also are heat. Nuclear, bits flying off of stuff, pieces of atoms, that all of that is a kind of heat, in the sense that it's motion that will be transferred to another atomic structure when it hits it. When electrons hit electrons, it's heat. Current in a wire is a kind of heat. It's all heat going in one direction.
We are all quite familiar with the concept of heat and can describe the sensation of feeling too hot or too cold.
Right, and it's just kind of, that's where your intuition is kind of a failure, because like I said, in the absolute sense, we function in a very hot environment. And so we have this illusion that everything below freezing is, it's just cold. And it's really not. There's a whole bunch of scale left, and it's all positive. It's all a positive amount of motion. It's not like you get to 0, Celsius or 0 Fahrenheit, and now you're in some kind of negative heat. You're still very positive. So the idea of the Kelvin scale was a really good idea. Now, I don't know if you need a scale that has, 20,000 degrees in it, but whatever.
But understanding what things like heat and temperature really are on the molecular level can be pretty tricky business.
And how they're created, and how heat is work. So there's just absolutely no difference between work and heat. It's exactly the same process. It's moving material objects, period. And also we know that heat comes in the form of radiation. So all of the radiant heat in the form of photons is also heat. It's not something else.
Nevertheless, we must fundamentally understand them as a prerequisite to learning about thermodynamics. So let's dig into this abstract concept.
So there's nothing abstract. It's about as elemental as you get. It's movement. And it's just movement of small things that are not even that hard to imagine, okay, in terms of atoms and molecules and clumps of small stuff moving.
We can start with temperature, like the temperature outside today. It might be hot, it might be cold, but in science, we want to quantify everything that we can. So saying something is hot or cold just isn't enough.
Right, it's all wrong in the sense of we shouldn't be even playing with the words in terms of what is hot and cold to humans.
We want to be able to say how hot or cold with numbers. But that begs the question, what is it that temperature is physically measuring? Temperature is measuring the amount of heat energy available for work in a system.
So again, available for work. So they're conceding that heat does work, even though they say in other cases that heat is where you lose, you have this entropy problem where everything, disintegrates into chaos and all those kind of arguments. When, of course, you can take advantage of the heat wherever it exists, as long as you can find a place that's colder, so to speak, that has less heat. That the heat always, the motion goes from things that are moving to things that don't move. Things that don't move can't make things move. Things that are moving make things that aren't moving move. And that's the simple elemental, back to push-pull almost. That these are things not taught, but that's the real truth of it. Things that aren't moving can't move anything.
And heat energy is related to the average kinetic energy of the atoms and molecules.
Right, so this is the bullshit part. So we're already throwing this kinetic energy nonsense in as if you square the velocity of the molecule and therefore it has more momentum, heat, motion than just the momentum. So there's just the momentum. There's just the mass and its velocity. There is nothing else. There's no evidence of anything else. And so all of this physics is nonsense because they pretend, because you made something go faster rather than making it heavier, that somehow you gave it more energy. So you crank the nozzle on the hose and you make the water go faster, okay, and somehow you have less water going faster, therefore you have more energy. And you really don't.
Within that system. We know that greater kinetic energy means objects will move faster.
So this is again, it's just a nonsense formula. It's never accurate. It's never the truth. They have no example of it ever working. It doesn't land man on the moon. It doesn't knock down more bowling pins. It doesn't show up in a ballistic pendulum. It doesn't show up in a tug of war between a 5-ton train going 10 miles an hour and a 10-ton train going 5. The kinetic energy theory says the 5-ton train wins decisively. It has twice as much energy. The actual fact is that it'll be a dead tie because the two objects have the same capacity to do work by a statement of they have the same capacity to move matter. They have the same capacity to move other masses. They have the same currency to give away. They have the same quantity of motion to give to another object, as Newton would put it. And they're completely rejecting Newton's physics, accepting Leibniz's physics, and it was never proven by any credible experiments, ever. They'll never show you a car crash where twice the speed is 4 times the damage, or 3 times the speed is 9 times the damage, or 4 times the speed is 16 times the damage, or 5 times the speed is 25 times the damage. They'll never show it because it doesn't happen. And I can't believe, I have to say this for years, it's at least 3 now, 4 years. and not one rational link to any kind of real evidence demonstrating that any of that crap is true, and yet you people defend it. It's dogma. It's religious gibberish. It's as dumb as flat earth science.
And this is true of molecules in the atmosphere just as it is of macroscopic objects. So higher temperatures simply mean faster moving particles.
So faster moving means twice as fast, twice the energy, as Newton would say. 3 times as fast, 3 times the momentum, as Newton would say. That's it. 4 times the energy. 5 times the energy. None of this quadratic increase in any kind of notion of capacity to do work. Spinning something 25 to 5 times as fast will not make it capable of doing 25 times the work. It doesn't happen.
This kinetic energy of
can't any of you people be honest and concede it doesn't frickin' happen?
motion is distributed amongst translational or side-to-side motion, rotation.
So the motion is always just, it gets a little bit complicated how you convey motion, but we know that every surface is essentially kind of elastic, and so the idea is as you put pressure in, just like if I'm on the earth and gravity pushes me in, I'm putting more pressure into the earth. I'm putting this into the earth. And the fact is somewhere that extra pressure wants to go back to its equilibrium. I've broken the equilibrium. I've created an increase in pressure that isn't equilibrium. And now somewhere else on the earth it's going to pop out. So that's the catch, is that the energy can take a U-turn. All right, so you put the energy in, you think it got absorbed, but what really is going to happen is it's going to pop out somewhere else. With the increase in pressure just means that everything else is going to be lifted a little bit. So you have a certain amount of water, you put something in the water that displaces the water, it increases the pressure of the water. So your motion down creates motion up in the water. So the water didn't move, the whole ocean didn't go anywhere. The surface just compensated for the amount of energy that went in and shot it back out again. So a lot of energy translations, a lot of transfers of energy are just with surfaces. And it never moves the whole object. The whole object doesn't even know it happened because it just went through the elastic part.
Or spinning motion, and vibrational motion, where the covalent bonds in a molecule bend and stretch.
So again, he calls them covalent bonds, but they're really just talking. What the hell was that? It's always something. I just don't get this whole YouTube thing. I didn't touch nothing. I have to fix it, I guess. All right, so I think we're at bend it, stretch or something, so see what happens.
Heat will flow from hot objects to cool objects.
Moving objects to less moving objects, or not moving objects, but it can't go the other way. Something moving slow, is going to have a hard time moving something fast. You can make it move slower. So the fact is something moving slow can make something bangs into it. And if it's dense enough, it's going to give its energy to the less dense object, a lighter object. And so it'll make it move faster and it will move even slower. But the point is that something not moving can't do anything.
Because as the particles move, they will impart some of their kinetic energy onto other particles.
So you can understand.
Hey, it's Professor Dave. Let's.
What the hell is wrong with this goddamn fucking thing? Really irritating. I just won't go anywhere near the play
flow
button.
From hot objects to cool objects, because as the particles move, they will impart some of their kinetic energy onto other particles.
Right, so if you change the mass of the particles, if the masses change, then the amount of kinetic energy that will be transferred won't be consistent. So you won't be conserving it like as you will the momentum. So momentum is always conserved. And as Professor Lewin says, you can deal with kinetic energy one way or the other, but nature can't finagle momentum. So momentum's the real thing, the real deal. There's only momentum. It's the only form of motional energy there is. And kinetic energy is a silly, nonsensical, completely unproven garbage theory. Okay, it's junk science. It's so pseudoscience in the sense that not a single credible scientific experiment demonstrating any of this to be true. The Mythbusters, just by accident, okay, tested it pretty thoroughly in the sense that they crashed two cars and there was zero indication of anything other than twice the speed, twice the amount of work done on the car. Not anywhere near any indication of 3 times or 4 times. So it's a garbage theory. There is no evidence, and yet why do physicists believe it? And they only believe it because they're taught it, not because they've seen it.
Through collisions. This will continue to occur until the whole system is at the same temperature, in a state called thermal equilibrium.
Right, so it's just the fact is you can change the temperature on one side and then that temperature will move to all the particles, but there's still going to be some particles that are going fast and some particles that are going slow, so it's only going to be an average temperature. There's still going to be elements of hotter and colder.
This is how thermometers measure temperature. Heat from the environment will be in contact with the thermometer and flow into the thermometer fluid, causing the atoms to gain kinetic energy, and the column will
So again, they're not going to gain kinetic energy, they're going to gain momentum, and they're going to be moving, and that is vibrating and banging into each other, and that's why the substance will expand. But they can't use like water because water doesn't do it as well. So they have to pick some kind of chemistry where it's more consistent with 99% of what things do. That is, they get bigger as they get hotter and smaller as they get colder.
Expand until it is in thermal equilibrium with the environment, thus allowing us to read the temperature in one of our man-made units. We must bear in mind that all phases of...
So you're just capturing a percentage of the thermal energy, and you're basically saying I am going to take the thermometer and give it the same equilibrium. Give the thermometer, that's why you have to give it time. You have to give it time to read the temperature because it has to reach equilibrium that's the same equilibrium of the substance you stuck it in, the same average.
Matter expand with higher temperature, whether solid, liquid, or gas. This phenomenon is called thermal expansion.
Right, and water is like an exception in the sense that it expands when you freeze it, which is really irritating, but interesting. And that's only because of the fact that the crystals actually are less dense than the liquid in the liquid form, so they trap air, essentially.
Energy is transferred as heat in a wide variety of processes. When a collision occurs, there is usually some heat generated. Friction.
So you could argue that heat is always generated in the sense that there's almost no circumstance you could describe where the energy moves through the object, even if it moves through as sound, as vibrations, that those vibrations couldn't be considered heat. So electricity is heat. Sound is heat. Vibrations of any kind are a thermal reality. So anything that is conductive because it's basically conducting heat, motion.
Can cause heat as well, which is why your hands warm up when you rub them together vigorously.
So we know that they do that because the energy you're creating is a bunch of little vibrations on the surface, but
in each case, we are considering the kinetic energy.
So again, he's using kinetic energy, and it's just momentum. All motion is momentum. It just matters about how big, how much mass, and how much velocity. And there's no idea that you give something twice the velocity, you gave it 4 times the energy, or you give it 3 times the velocity, you give it 9 times the energy, or you give it 4 times the velocity, you give it 16 times the energy. It doesn't happen.
Of the particles and the transfer of some of this energy to other particles as the definitions of heat and heat transfer.
And it doesn't happen. So again, an 8-pound bowling ball going 16 versus 16-pound ball going 8, they will convey the same momentum to the pins. Nothing else. The pins will receive the same total momentum. When you add up all the pins hit and all the pins moving after the collision, and both of them will, that total will be exactly the same. There'll be a higher differential for the 8-pound. The fastest pin will be faster, but the total amount of pins moving won't be any different. The total amount of mass moving. All there is momentum.
Heat is therefore a kind of energy in transit and will be measured in joules just like any other kind of energy. Furthermore, the transfer of heat energy,
so you can measure it in watts, okay, which is to me a lot better, but whatever.
will always alter the temperature of an object, as heat will always flow from the higher temperature object to the lower temperature object until thermal equilibrium is reached. This is why hot objects feel hot and cold objects feel cold, because a hot cup of coffee, which is hotter than your hand, will transfer heat into your hand, while a cold piece of ice, which is colder than your hand, will cause heat to be transferred out of your hand.
And the two things end up feeling very similar, so I don't know exactly what he's saying there, to some extent.
And into the ice. These events produce the hot and cold sensations we feel in.
So it's too bad that he's wasted time on the sensation stuff and hot and cold relative to human beings and didn't really get to the things that are really hot, like suns, okay? And what is making the sun hot? And the simple answer is gravity. So gravity is creating heat. And if gravity is creating heat, how can there be thermodynamic conservation of energy? Because there's no mechanism to convert heat into bent space, time. So obviously bent space, time isn't the right answer. Not even close to the right answer. So just remember the analogy. I think it's a good one. So there's a cloud above you, big giant thing, and all the rain is going to come down on you in the center of the earth. So you're in the center of the earth, and you can just imagine that all of that weight is now going to be on your head, so to speak. And then you can think of it exactly the opposite way, that if you had all that weight on your head and you dissipated all of that force across all of that huge amount of space above you, that it would all come back down to being not nearly as hot, right? So by the time you get to the surface, it doesn't look like 4,000 degrees anymore. But it's still, if you add up all the little bits of matter moving, it's the same. So the heat in these different layers of the earth are a representation of taking something very hot in the center and spreading it over a huge amount of mass. And so the temperature drops, but it's still pretty damn hot. So the earth is, there isn't, you don't have to go very far down before you're starting to get to a part of the earth that is glowing. And so it's really just the crust, that looks cold.
In our day-to-day lives. Now that we better understand heat and temperature,
so
let's
this was no understanding. It didn't really talk about any of it in any kind of get to the real argument. And he threw in this stupid false dogmatic statement that there's some kind of kinetic energy involved and that you quadratically increase the amount of energy something has by increasing its velocity as opposed to increasing the mass moving. So again, he's saying that two 100-pound football players, going twice the speed, have more energy. Did I say that the right way? Than, one 200-pound. Of course they would. But anyway, you get the picture. If I put the energy in smaller things moving faster, they're going to argue I have more energy when I don't. So if I have a 100-pound player going twice the speed or a 200-pound player going 1 unit of speed, I have the same capacity to give the quarterback a bad day.
That comprehension.
I mean, I suppose you could argue that the quarterback can see the slower guy more likely and evade him, but the point is the impact energy is going to be the same. All right, so we don't bother with these little silly quizzes, just a waste of time. So anyway, jerk. So we can't get any of these people to respond to any of these assertions. So I'm saying, please, don't bother ridiculing me or wasting my time talking about how dumb I am or any other kind of crap. Just link me to your evidence. Show me something somewhere that indicates that 5 times the velocity equals 25 times the capacity to do work. Just show me an example of that somewhere. And if you can't, then maybe you ought to think about that and say, you know, why can't I show him the evidence? Why don't they have it? Why can't I show him the evidence of 4 pounds dropped 1 foot equaling the same amount of energy as 1 pound dropped 4 feet? Why can't I show him that? Oh, it's because it doesn't happen. That's why. That's what you should realize. It doesn't happen. Their physics is about a bunch of crap that doesn't actually happen. They have surmised it, supposed it, invented it, but they have never tested it. Oh, it's so bad. Again, they invented quarks by watching electrons deflect. You know, I don't know. Is that going to prove the existence of a quark? I don't think so. All right, so it's just terrible science. And it's really terrible that you people can't recognize that it's terrible science and say, yes, this needs to be done much better. They need to prove what they say. They can't just keep saying this crap. They actually have to show something that works and it's happening. Show me the car crash. Show me something that indicates their physics is true. Show me the Eddington experiment done from space. Show me the light being bent by gravity, not by scatter, not by some other mechanism. Show me gravity bending it. The experiment takes 5 minutes from space, 400 times better resolution, and we're supposed to believe they never even tried it. It's a $463 experiment. So just imagine they'll spend billions and billions and billions of dollars on abstract nonsense, neutrino detectors, all kinds of silly crap, and they won't spend $500, okay, to show you light bent by gravity. It's disgusting. Disgusting that you people fall for it and defend it. Ugh.